Okay, so today we're going to talk about latitude problems, and you're probably saying, like, what the heck is that? They're actually, like, once you see them, they're pretty, like, not terrible. So that's good. So what we're going to do is we're going to be plugging into the arc length formula, which we'll remind ourselves of. What is that? What goes where? I'll tell you kind of, we're going to be given the latitude of two cities. I'll tell you how to find the angle between them. It's pretty quick. And then we'll just go through these steps. A lot of the steps are review of what was on your quiz yesterday. So once again, if you got the quiz back or if you looked at your grade and it wasn't the best, then that just means get some help if you need it. So I'm happy to help you always. You just have to ask. So that's what kind of drives me crazy on a quiz day when you say you don't know how to use your calculator. I ask multiple times, hey, does everyone know how to use your calculator? And no one tells me that they don't know. Like, you got to tell me. Hello. I can always help you, but you got to tell me. So if you're just writing in your notes, you don't need to write this word for word. You can just kind of do like, the Cliff's Notes version. So you don't need to write, you might want to write things like, oh, the latitudes and the distance, but I'll kind of give you that heads up as we get there. So here we go. So I would label the top of your notes, just write latitude problems. So that's what this is. If you printed this, great. If you didn't, it's not a big deal. So today we will focus on using the arc length formula to find the distance between cities. So let's remind ourselves of what the arc length formula is. It's S equals R theta. And then the big thing, that's a weird theta, is theta has to be in radians. Okay, so I like that formula. It's quick. There's nothing weird about it. It's like you just throw stuff in, you're done. But we just need to know which one we're using. Okay, so we have this little formula. That's exciting. And then we're going to have some latitudes here, like 28 degrees north or 12 degrees south, or there's other ones and other problems. So how do we find the angle between those cities? So if they're in the same direction, AKA they're both north, 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 or south, south. These are not in the same direction, right? One's north, one's south. So we'll talk about that in a second. If they're in the same direction, you are going to subtract your angles. Okay, so that's not bad. If they're in opposite directions, that's what this one would be, right? North, south. Excuse me. So north, south. Then you are going to add your angles. Okay, so as of right now, that means nothing to you, right? I'm just writing it and you're like, I have no clue what you're even talking about. So for now, just kind of make a note of that because that's something we'll refer back to in a minute. So I'll give you a second because I know it takes a minute to write stuff at home. If I ever tend to, sometimes I like get into it. If I tend to rush, please feel free to be like, slow down. So once again, right now you're like, I don't even know what you're talking about. Just write it. We'll refer back to it in a minute. It's just one of those things you kind of need to start. So what happened is I have like all the, I have like a million things. I've been teaching trig for a while. Probably like, I don't know, 12 or 13 years. So I have all these resources and worksheets and all this other stuff. And all of my like application problems like these were mixed. So like we have latitude problems, we have clock problems. We'll do those next week. We have problems with gears. We had problems with area. And I had them like, one of each. I thought that would be way too confusing, especially like being at home. It's just like not the best learning environment. So I decided each day, and we're not even going to do all of them. We'll kind of just focus on maybe two types of problems. We'll just like have one type of problem and just focus on that one thing. So we're not kind of bouncing around to all different things. I feel like that makes life a little bit easier. It's just like easier to organize your brain when you just focus on one thing. So we'll just focus on these problems today. And then we'll kind of see a little bit different stuff next week. Okay, so let's do our example. We'll use that information that we just wrote down. I'll kind of show you just the idea. So you don't have to draw a picture every time. I'm just drawing it for the first two just to kind of, so you can visualize what's happening type deal. And then we'll just talk about how the heck do we plug it into this equation or formula. Okay, so when I say draw a picture, what we're thinking for these two cities is we are trying to find the distance in kilometers between two cities. One has a latitude of 28 degrees north and one is at 12 degrees south. And we know the radius of, or we don't know, but I'm telling you, the radius of the Earth is 6,400 kilometers. How exciting. So when we're talking about cities on latitude, we're talking about the Earth here. So when I say draw a picture, you draw a circle that represents the Earth. When we do latitude, we do it from the equator. The equator is the middle point, right? So equator is kind of the middle. And then from here, you can go north or you can go south. So when I say that one city is at 28 degrees north, just think like from this, I mean, I'm like totally estimating. From the equator to here, I'm going to say is 28 degrees. So that means the city would be right here, right? Our cities are on the circumference of the earth. So that would be that city. The other one is at 12 degrees south. So from the equator, 12 degrees, I don't know, we'll say is about right there. So remember, all of our measurements are done from that middle point of the equator. And then our main goal is to find what's this distance. Because once again, the earth is not flat, right? The earth is curved. So this is why we need to use that arc length formula. So that's kind of the idea. You don't need to draw that every time. It's just kind of getting used to what the heck we're thinking about. So one is north, one is south. We're trying to find the distance on that curve. Okay, so let's go. Find the angles between the cities. So this is why I needed this up here. These are in opposite directions, right? One north, one south. So if they're in opposite directions, to find the angle in between, we're going to add the angles. So I'm going to take 28 degrees and I'm going to add 12 degrees to get my angle of 40 degrees. Okay, so that wasn't too terrible. So I'll just do a little pause after each part just so you can write it down. So opposite directions you add. But we know back from up here, when we need this formula, our theta has to be in radians. So our next step is to convert the angle to radians. Okay, so we'll just kind of do that every time. Once we find the angle in degrees, we'll convert it. So just as a reminder, how to convert, we take the angle that we're using, which is 40, and we're going to multiply it by pi over 180. Okay, so since that gives me 40 pi over 180, I'm going to now reduce this. So just as a reminder, if you don't have a scientific calculator, use that one, that Desmos one online. I think I actually plugged in 40 over 80 because I looked at my my worksheet real quick. But I remember, don't put the pi in when you're reducing these. So when I reduced that, it came out to 2 over 9. So we would say this is 2 pi over 9. So basically, anytime we're in this chapter, we're going to need radians. So if you see a degree, you just convert it. So that's the big thing. Plug into the formula. We can do this. You guys were doing this on that quiz yesterday. The formula is S equals R theta. I'm trying to find S. I know R because it was given to me in the original problem. The radius of Earth is 6,400 kilometers. So that would be 6,400. And then theta, we're using the radian. Remember, that's why we just did that step. So that would be 2 pi over 9. And then we're going to plug that baby in. So I'm just going to use my calculator. If I had it out, that would be semi-helpful. You know what? I'm going to use the calculator that kind of a lot of you use. Hello. Okay, so here's my calculator. And just as a reminder, if I'm plugging this in, I'm doing 6,400 times, I use parentheses. I'm a big parentheses user. So I'm going to do 2. I'm going to find my pi symbol. I can't see it, so sorry. See how it's like above right there? So I'm going to hit shift and that key. And then see my pi is in because I just want a decimal. And then divided by 9. So 6,400 times 2 pi over 9, and I hit enter. And I get 4,468. Now we're on to 2 decimal places, 0.04. When it says label your answers, we should write kilometers with it because it is a distance. And that would be my final answer. So basically, yesterday when you were doing the quiz, you basically for some of the problems, you started with a degree, you converted it to radians, you plugged it in, and you solved it. So basically, the only thing we're really adding is just taking into account, if I have these two angles, how do I find the angle between them? That's it. So it's really just adding one step to what we've been doing. So I'm going to leave that up for a second. We're going to do one more example together. And then there's a few examples on the back we'll kind of set up, and then you guys will try a few on your own. So once again, we've only done one. We'll do a few more. I just want to leave that up for a second, and so you can write it down. Oh, excuse me. Okay, so we're going to start example 2. So I'll kind of leave that up as I'm reading example 2. So 2 cities are on the latitude, so it starts the same way, of 72 degrees south and 34 degrees south. So in this case, they're in the same direction. They're both south. What is the distance between the 2 cities? Or the radius, like the radius of the Earth doesn't change, right? The Earth is the Earth. So you're always going to see that 6,400 kilometers there, but the thing that's changing is just the angle. So when I say draw a picture, once again, you don't need to do this every time. I was just doing it so you could kind of visualize to start. But on the back, I don't have you do this step unless you want to. So I'm going to start example 2. Here we go. So example 2. Okay, draw a picture. Sorry, I got distracted here. We got the Earth. We got the equator. Right through the center of the Earth. One of these cities is at 72 degrees south. So from here, I'll say like about there is 72 degrees. The other city, sorry, I'm always like at a weird angle here. The other city is at 30, oh my gosh, excuse me, is at 34 degrees south. So I'm going south again. So like the other city is down here. So one city's here, one city's here. So we can see in the same direction, it made it a smaller angle, right? Because we just need to find this angle here between the cities, because that's the distance we want to find. So it kind of makes sense when they're in opposite directions, it makes it large, so you want to add them. When they're in the same direction, just as a reminder, we wrote this before, we're going to subtract them because it makes it smaller. They're closer together. So I'm going to subtract my 2 angles for B. So find the angle between the cities. So that's 72 degrees minus 34 degrees. And once again, I'm subtracting because they're both in the same direction. And that's going to give me 38 degrees. Okay, so we have the angle. We actually have everything we need, basically. We just need to convert it so it's in the correct measurement and then plug it in. So converting to a radian, we know how to do this. We're going to take our 38 degrees and we're going to multiply it by pi over 180. That gives me 38 pi over 180, but I'm going to reduce that. And when I reduce it, I'm going to plug it into my calculator without the pi. I'm just plugging in the 38 over 180. You can use that online calculator now, and it will reduce it for me. 38 over 180 reduces to 19 pi, or 19 over 90. And then once again, I put that pi with it. So try it in your calculator, or maybe open that online calculator and see if you can do that. But we have everything we need because we have the angle and we have the radius. So now we're going to plug into our formula. Excuse me. So S equals R theta. R is always the same. It's 6,400. The theta I'm using is the radian. So that's why I kind of set it up like this. So you're just kind of taking what you just found and plugging it in. And then we just use our calculator. So I'll grab mine again. I'll kind of show you what I'm doing. Clear? So we put in 6,400 times, I always like to do parentheses when I have that fraction, 19, I'm going to put in my pi symbol. So I'm going to do shift. I'll put in that pi, and I'm going to divide that by 90. Okay, so everything's plugged in. Beauty-os. I press enter. It's going to give me my nice answer. And the answer is 42 of 40 of 4.64-ish kilometers. Oh, whatever. I was supposed to label it over there, guys. I put it there. It's the same thing. It's just make sure when you label your answer, you do put kilometers with it. Okay. So I'm going to leave that up for a second. And sorry, it just keeps shifting. So I'm going to put that there to as a little weight. So in those ones, I kind of broke down each step. On the back, I don't like make it as detailed. So if you forget what you're doing, feel free to refer to the problems we just did. But on the back, I just kind of say like, find it, and then we'll go through the steps again. But I don't list them out every time. So I'll give you another second to get caught up. I think I would know the schedule of this year. Okay. So we'll do, I don't know, like 5 to 7 more minutes of like doing problems together. And then you guys will try a few and just see how you're feeling. Okay, so I'm going to flip-a-roo. So once again, this is more just for me to stay organized. I know it's kind of a pain if you're printing everything at home. Dude, that ink is expensive. So feel free to just write it. So let's try these. So these are, you should be able to do because they're a quick step. You're either adding or subtracting. So let's see if you can remember, okay, if you can just look at your notes. So what is the angle between the two cities? It doesn't ask you to do anything else. So I just want to know, just in degrees, you don't have to do anything fancy with radians. So I'll just even make a note to myself in degrees. Can you figure out right now? I'll give you like, I don't know, a minute, right? Because you're either just adding or subtracting. It's super quick with a calculator. So just as a reminder, look in your notes. If one says north and one says south, what do? Do I add or subtract? Can you add or subtract them? If they're both north, what do? If one's south, one's north, what do? And if they're both south, what do? So can you figure those out now? I'll give you a few seconds. It's just looking back. Remember, I have it written right here. You should have it written in your notes somewhere, whether you add or subtract. That's why I wrote that. Okay. So take a few seconds and see if you know that, because if you can do that, you can basically do any problem at the bottom. So I'll give you like a minute, and then we'll come back together and check those. Squeaky thing. Excuse me. Oh man, I'm dripping everywhere. If you ever need help, feel free. You can just throw it in the, sorry, in the way of my thing. Oh, Mrs. Sherman, me and that. There we go, guys. All right, let's check those ones quick because we were just adding or subtracting. Hopefully it wasn't too bad. Once again, if you don't have a calculator, one, you could use a phone calculator for that. Like that's not too detailed, but there is that online resource. So, sorry, I'm just at a weird angle here. I don't know what's going on with my life. Okay. So in this case, you just need to see, oh, north and south means I'm going to add those. That's it. So that's basically the main thing you're looking for. And that answer should be 42 degrees. So do a quick check. In this case, I have a north and a north, which means I'm going to subtract those. Just as a heads up, it didn't matter what order I gave these in. Like I could have said 12 degrees north, 55 degrees north. Always subtract them so you have like the larger minus the smaller. You don't want negatives. So you can always change the order if you need to, but always do larger minus smaller. But it was already in that order anyways. And that came out to, excuse me, 43 degrees. My voice is not working today. South, north, opposite, add. 29 plus 15 is 4. Guys, I didn't even plan this. I was like doing the answer key. I was so excited. This was 42, 43, 44. Can I do it with the last one? South and south, I subtract. It came out to 49. I was so mad that it wasn't 45. I don't know why they were all in the 40s. I just like randomly made numbers up, but there you go. So just knowing opposite or same, do I add or subtract? Does anyone have a question with 1 through 4? Excuse me. My voice today is just not where I need it to be. Okay, so then we just have a few more examples. So I'm going to do one more with you. So I'm going to do 5 with you. I'm going to have you guys try 6 and 7. There's 2 more at the bottom, 8 and 9. We'll do those as like warm-ups next week. So it's okay if we don't finish everything. We'll live, right? I'm sure you're
Sherman.
Yeah, what's up?
I have a question.
Sure, what is it?
What is number 1 again? I got 45.
Is
Yeah,
it?
I did too.
Oh my God, oh my God, hold on. It's totally 45. I don't know where I got 42. Thank you. Let me change it. Hold on, let me get my little whiteout tape. Thank you. Yeah, I must have just gone crazy yesterday. I was trying to do a million things at once here. Oh, gotta love the whiteout tape, guys. 45. Okay, there we go. Thank you. Okay, so I like the 40s. Yeah, always correct me if I do something wrong because it happens often. Okay, so let's do number 5, and then I'm going to have you guys try 6 and 7. And those are the ones I want to kind of see your notes and those ones, and that will give you credit for today. So number 5, we have 2 cities. You don't need to, once again, you don't need to draw the picture.
Mrs. Sherman.
Oh yeah, what's up?
This is Katie. Sorry I'm
Hey,
late,
Katie.
but I'm here now.
Okay, thank you, Katie. Thanks for letting me know. So you don't need to draw a picture. It was more just so you could visualize what the heck we were finding. You're more than welcome to draw the picture if you would like. But the main thing you need to do is look at this, basically do the step that we just did. That's like the main step to find the angle between them. I see that I have a north and a south, which means I'm going to add those. And that's going to give me my theta. Okay, so I'm going to add 51 degrees plus 12 degrees. Now I'm like second guessing myself. No, I can do that. That's 63 degrees. Okay. So now we have an angle between them, but it's in degrees. So I just kind of keep going on with this instead of doing like all separate steps. So I'm just going to take that degree and I'm going to convert it to a radian because for our, whatever that's called, formula, if I could use my brain today, I need it in radians. So I'm just going to kind of work right off here. 63 degrees. I'm going to convert it now. Convert to radian. I'll just say convert. I'm going to multiply by pi over 180. I'll get 63 pi over 180. And then once again, I'm using my calculator. So let me use this calculator just to remind people how to do it if you have one like this. If I want to do 63 pi over 180, I'm not going to put the pi in. I'm just going to do 63. I'm going to hit this button, this one that looks like ABC. It kind of looks like there's a little fraction in there. So that means, I know it's a kind of a weird symbol, but it just means it's making a fraction for me. And then I put in 180. So what that's going to do is when I hit enter is it's going to give me a fraction that's reduced. So if you have a calculator like this, a lot of them will have that button. Some of them have a button that actually looks like a fraction, which makes more sense to me, but so it reduced it for me. So this would be 7 pi over 20. So once again, I don't put the pi in. I kind of reduce the fraction and then just add the pi back in on my own. So now this is what I'm going to use as my angle because I needed it in radians. Once again, steps we've done. The only really new step is adding those to get one angle, and then converting it is what we've been doing. And then we can plug into a formula. So my formula is S equals R theta. So S equals R is always the same for these, right? For every single problem, because the radius of the Earth does not change. So it's always 6,400, but I'll always remind you that you don't need to know that. And then the angle is the radian, which is 7 pi over 20. So I grab my calculator or I go to my online calculator. I'm going to plug in 6,400 times, and then 7. I'm going to put the pi in. So remember, I find my pi symbol. Oops, that's not the pi symbol at all, Mrs. Sherman. Okay. Pi symbol. There we go. And then over 20. So that's how I plug it in. And it's going to give me a nice old answer, 7037.17. And I label it with kilometers because it's a distance. And that would be my final answer. So just kind of putting a lot of things together that we've been doing, whether it's converting to a radian or plugging into a formula. The main new step is if I have two angles, how do I find the angle between them? So once again, opposite directions you add, the same direction you subtract. So I'm going to take a moment just for you guys to get caught up, see if there's any questions, and then you guys are going to try 6 and 7. Oh, I have an itchy nose. So if you have a question, feel free to ask. You can, thank you. I see some things. Oh, thank you. You can tell I like look back and forth at the chat and I get distracted. So thank you. I saw a few comments in the chat, so thanks. Okay. So if you need help, let me know, whether it's with a calculator, whether it's with just like you don't know what's going on. And we'll go from there. So you guys are going to try 6 and 7. So I'm going to put them up. I'll leave them up. When you are done, you are going to scan your notes from today and make sure I can see 6 and 7 is the main thing, because I'm going to go through and kind of check if people are on the right track. And then once it is scanned, you are allowed to sign off. So you don't need to tell me. P.S. I know if you've done it because it's scanned into Google Classroom. So that's why you don't need to check in with me, because if you sign off and you're not in Google Classroom, you're not even getting credit for being here anyways. So that's the thing that's giving you credit for attendance, is actually participating. Okay. So you don't need to do 8, so that's why I just don't. Let me cover 8 here. All right, so we got 6 and 7. So you guys are trying these ones. So just as a few reminders as you're trying them. For each of them, you have your latitudes. So the main thing I check is same direction. So this one you would subtract, or up. Oh, those are the same direction too. So that one you would also subtract. So finding that angle between them, converting it to a radian, plugging into your formula, and then labeling your answer. And once again, all those steps we did in all the other ones. So just try to follow a previous problem if you're ever stuck. Or once again, you can always ask me a question. So you're working on that for the next few. Once it is scanned into Google Classroom, I'm going to have my kind of Google Classroom open. You are welcome to sign off of the meet. But until then, kind of stay on just in case there's technical difficulties or you have a question or anything like that. And that will be class today. That was yesterday. I'm just going to play with the screen for 1 second. So I'm sorry if it goes off, but it'll come right back up. I just want to stop recording because, oh God. So sorry. I know I just totally